In this video, I'll be discussing traits. Traits are simply a way to specify that some functionality exists. They are used to standardize functionality across multiple different types. Standardization permits functions to operate on multiple different types. The end result is you end up with code deduplication. Normally, with functions, you would need to write multiple functions if you want to work with multiple different types. And if those types all exhibit some similar functionality, then you can use a trait instead. So you would only need to write one function that operates upon a trait, and then you can call that function with multiple different data types as long as they all implement that trait. Let's take a look at an example. Here we have a trait. Traits are created using the trait keyword, followed by the name of the trait. You'll want to name your trait with a capital letter. Within the body of the trait, we can define functions that describe what the trait does. So here we have a new function. It's called makeNoise, and it accepts a reference to self. Usually with traits, you'll have a self reference. That way you can easily access the trait functionality when you go to use it later. In order to implement traits, you need structures or enumerations. Here we have two structures on the right. So for our person structure, we're implementing the noise trait. To implement a trait, use the impl keyword, and instead of specifying the structure enumeration, you instead specify the name of the trait, along with the keyword for, and then the name of the structure or enumeration. So this reads, implement the noise trait for the person structure. Then within the implementation block, you'll list out all of the functions required for that specific trait. Here on the left, we can see that our noise trait only has one function, so you only need to specify one function within the trait implementation body. The function signature here has to be identical to the trait function signature. Within the body of the function, you'll then specify however the particular structure should implement that functionality. So for a person, if they make noise, it's going to print out hello. Next, we have a dog structure. So here we're implementing the noise trait for a dog. And when the dog makes noise, we print out woof. Over here on the left, here's how we would utilize this information. We have our main function, and it calls a function named hello with a person, and it calls it again with a dog. The hello function has a function argument named noisy, and the type for that function argument is something that implements noise. So this is read as the type is something that implements the noise trait. Within our function body, we have our argument. So this may be an enumeration or a struct. We don't know as long as it implements the noise trait. We then call the makeNoise function that's defined up here on the noise trait, which will then call the makeNoise function on the appropriate piece of data. So on this first one where we have hello with a person, when we call noisy.makeNoise, this makeNoise function will refer to this one for a person. So it'll print out hello. And then for the dog, this makeNoise function will refer to the implementation on the dog, which will print out woof. You aren't just limited to single functions within a trait. You can also have additional functions listed for the trait depending on your needs. So in this trait, we have something called racer. So this trait could represent a particular racer in a game. Maybe you can race different types of vehicles. The functions we have defined here are go, which would signify how you start the race. Is ready, that could signify whether or not the racer is ready. And it can also return values. So here we return a bool. So true would indicate the racer is ready, and false would indicate that they're not ready. And then finally, we have a checkpoint function, which could be called whenever the racer hits a particular checkpoint, and then it passes in the current position that they're in. So maybe if they're really far behind, they may want to take more risky maneuvers, or if they're really far ahead, maybe that particular racer may want to play it safe so they don't lose their position. To recap, traits define similar functionality for different types. Trait functions are just regular functions. They can accept arguments, and they can return values. In general, you almost always want to have a reference to self in your trait functions. You can also use impl trait as a function argument to pass data via traits.